Alright, welcome back. We're still in the chapter where we convert words to vectors. And in terms of word embeddings, we've seen word2vec. We discussed continuous bag of words and skip-gram. But there's another technique called GloVe. GloVe is global vectors, and it was released in 2014. So how do we get to GloVe? Well, let's summarize of what we've seen in word2vec, and let's take a look at a direct co-occurrence count. Yeah? So in word2vec, remember, the cat jumped over the fence, we had a corpus, we defined a window, and we just slide that window over that corpus. So basically what you do is you capture co-occurrence one window at a time. Yeah? So in the end you have, for each word you have a context representation, VC, and for each word you have also a center word representation, VW. Yeah? And based on what you do, CBA or skip-gram, you have one and you predict the other. So it's a prediction-based technique, right? Now you could say, why are we doing this sliding window? Why don't we just go to the corpus and we count how many times deep and learning appear together, and we make that count, right? So here is direct occurrence, an example of a very small corpus. The cat jumped, the cat and the dog point. Yeah. So here you're just gonna count. Yeah, after the, so here assume that it doesn't matter if the word is before or after, so you assume symmetry, and all these will be 0. Alright? The in front of cat is 1. The in front of cat is 2. Yeah? And because it's symmetric, it's 2 here. The in front of jumps is nothing, but jumped has the after it, right? So here is 1. Then the and ant is 1. Ant and the is 1. Yeah. And then we have the and dog is also 1. Alright? Now we have cat and the is 1, 2. Cat and jumped is 1. Cat and ant is 1. And cat and dog is 0. Alright? Now, here jumped and ant is 0. Jumped and dog is 0. Yeah? And then we have ant and dog is 0. Alright? So now we're just gonna do a symmetry. 2, 1, 1, 1, 2. Okay, this is all 1. This one is 1 here. This one there. 0 here. So symmetric, meaning is 0, 0, 1, 1. So this is gonna be 0. It's gonna be 0, and it's gonna be 0. Yeah? So we just count the co-occurrence, and we don't mind if it's before or after the word. And here, of course, you already see your vectors, huh? Right? This could be one vector. Alright? So it's another way of making these word vectors. Now if we compare the word2vec, which is prediction based, with a direct co-occurrence count based, we know the following differences. In word2vec, we remember we had these two matrices, Wi, W0 or WO, and we gotta update all of these every time we slide that window. So it's not a very efficient method to do, and it does not scale well, right? We've seen that. Whereas here, you just do your count and then you do your update. Yeah? So you do your count, you go through all the corpus, and you just say, okay, occurrence of this pair is 3,200 times. Yeah? So it allows for faster training here. Now, the constantly updating your parameters is more in line of what we do in deep learning. Yeah? The direct co-occurrence count is a different type of learning regime. Yeah? We've seen that word2vec is computationally expensive because of these softmax properties here, but we've seen that we can tackle this by doing negative sampling or hierarchical softmax. Now imagine if you have a vocabulary of 100,000, then this is 100,000 by 100,000 matrix, and there's going to be a lot of zeros in that matrix. It's called sparsity. Yeah, so you require a lot of storage. What you can do is reduce the dimensions, and we've seen basically three techniques. We've seen PCA and SVD, yeah? And we recently also saw T-SNP. Yeah? If you want to know more about these, look at videos 45 to 50, where I explain what PCA and SVD does. But you can reduce your dimensions. Yeah? What you can also do is you can define a cap for high frequency words like the or. You know, that you say, you know, if they appear more than 100 times, I just keep 100. Or you can simply ignore these high frequency words. Yeah, that's another option. Now, we know that SVD is computationally expensive. So you decompose a matrix in 3 matrices. So when the dimensions are high, this is not easy to calculate. And your SVD, you need to rerun every time you add words or text. Yeah? So this can be quite expensive to do. Now the direct count occurrence here only gives you a sort of similarity between your words. But we know that word2vec, these capture more than just similarity. Remember that if we take king minus man plus woman would give you queen. Yeah, something like that. And this is something you don't have here. Yeah. Now what is GloVe? Well, in GloVe you capture all the benefits of both worlds together.